A cross B will be a vector perpendicular to both of them. This is A cross B with an upward direction. Guys. So how do we know the direction? So for this, we use right hand thumb rule. Okay. So if you are writing A cross B, and A cross B is given to you, something like this. So rotate towards A to B. Rotate from A to B. And while rotating this, use your right hand. So come from A to B, and your thumb will be upside, right? If you're coming from B to A, then your thumb will be downside. So B cross A will be having a direction which would be represented as something like this, perpendicular, but with a downward direction. This is B cross A. So use your right hand, put it on the first vector, and then roll towards second. In doing so, wherever your thumb is pointing, that direction is A cross B. So this would be B cross A. Now this is the direction which is for B cross A, right? Now, if I talk about A cross B in geometrical sense, then we have this vector which is pointing upwards, right? This is at A cross B. Now, this is only direction, right? So we can use n cap for this. We generally use eta cap. We call it as eta cap or n cap, right? So this is the direction for A cross B, which is basically perpendicular to both A and B. Guys, am I audible?
Yes, sir.
Did you write that? Whatever I have written.
Yes, sir.
Okay. So A cross B geometrically can be signifies through this. And if we talk about A cross B, how do we see it mathematically? Then it is just like solving a determinant. Now, what is the determinant? So let's say you have A vector as A1i plus A2j plus A3k, and B vector as B1i plus B2j plus B3k. So the value of A cross B would be mathematically given as, if you solve this determinant, ijk A1, A2, A3, then B1, B2, B3. The value of this determinant would tell you the value of A cross B. Now, how is it happening? If you solve the determinant as well, you'll get this value. Let's understand how the process of vector product is happening. So we know that A cross B, we know this formula that A cross B would be equal to mod A, then mod B into sine theta, where theta is angle between them, into a vector perpendicular to both of them, right? Now, if I multiply I with I, let's find out what is I cross I. So if you multiply I cross I, the magnitude of I is 1, then again the magnitude of I is 1. The angle between I and I is 0. So it is sine 0, which makes this as 0. So when you multiply the same element in cross product, they become 0. Now let's see what is I cross J. So if I multiply I cross J, I will get what? I is this direction, x-axis, right? Now y is this direction, y-axis. This is J, this is I, and the perpendicular would be some this k direction, right? This is for z-axis, and this is for x-axis, and this is for y-axis, right? So if I multiply I with j, I cross j would be what? Magnitude of I 1, magnitude of j 1 into sine 90. The angle between them would be 90, which is again 1 into a vector perpendicular to both of them. Now this is I, this is j. If you roll from I to j, so if you roll your fingers like that, then thumb will point upwards. That is positive k. So I cross j would be k. Similarly, j cross I would be minus k. Just change the direction because you have changed the order. If you're changing the order in case of cross product, the value will change. Why? Because now you are rolling from j to I. So the vector, direction of the vector will change. Right? Some of the key points are, or you can also call them as properties. First is A cross B is equals to minus times B cross A. Second is I cross I, J cross J, K cross K, or in general, any vector cross any vector is equals to 0, because the angle made between the same vector is 0 and sine 0 is 0. Now IJK follow a right-handed system. Right-handed system money I cross J would be equal to K. So this revolves like this. I to J, then J to K, then K to I. So if you are multiplying K cross I, you will get J. If you are multiplying I cross K, then you are reversing the direction. So you will get J, but minus J. So I cross J is equals to K. Then J cross K is equals to I, and then K cross I is equals to J. If the order changes, then you will multiply and you will put a negative sign. Now, think about when will be A cross B 0? How can A cross B be 0? A cross B is mod A mod B into sine theta, right? Either it can be due to mod A or it can be due to mod B. In that case, A and B has to be a 0 vector. But we will consider that A and B are non-zero vectors. A and B are non-zero vectors. So how can their cross product be 0?
If A and B are collinear vectors, or angle between them is 0.
Yes, right. So it can only be 0 due to sine theta, which means that theta has to be 0. Theta will be 0. It means that either the vectors are parallel or collinear, right? It means A and B are parallel or collinear. Okay, can I remove this? If somebody is writing, just raise. Cool. Two more properties related to this. 4, 8. Fifth is that if you have, let's say, two adjacent sides of a triangle. So if you have two sides of a triangle, let's say this is a triangle. This is a triangle which is known as some triangle ABC. Let's say this side is A, right? And this side is B. You know two of the sides of the triangle. If you know two sides, then you can also find out the area of that triangle. Right? So area of triangle ABC would be half A cross B magnitude. Half magnitude of A cross B. Which can also be written as half mod A mod B sine theta. So if you know two sides of the triangle, you also know the area of the triangle. And similarly, let's talk about a parallelogram here. So if you take a parallelogram, in that case also, parallelogram is what? Double of triangle. Nothing but double of triangle. Right? So let's say this is a parallelogram, ABCD, and we know the two adjacent sides of the parallelogram. Obviously, this side would be A vector only, right? And this is B. So if you know A and B, so area of parallelogram ABCD would be the magnitude of the cross product of A and B. The magnitude of the cross product of A and B. Now, how is this happening? You can understand that very easily by the way. So you know the area of this triangle, area of this triangle is half base into height. So area is half into BC into this perpendicular AD, right? Now the length of this perpendicular can be found out in terms of A and theta. Now sine theta here would be AD by AB. Hence AD can be written as AB sine theta. AB sine theta means AB can be written as AB vector, magnitude of AB vector into sine theta, which is nothing but this, B into sine theta, which is this. And after this, we can move on to this step. And similar concept is used in parallelogram as well. Just remember these two concepts, you're good to go. That if you know two sides, you can find out the area of a triangle and also find out the area of a parallelogram. Okay, one small thing. So yesterday we have studied about it. Let's say we have these vectors, A vector plus B vector, and we are taking a dot product with another vector, X vector plus Y vector. So how do we do this? We will take A with X first. So A dot X, right? Plus A dot Y plus B dot X plus B dot Y. The similar way will happen when we cross multiply two vectors. So let's say this is A plus B and this is C plus D. and we are taking the cross product of them. So A cross C. Now remember, the order is important now. So we are multiplying A with C, then A with D. So A would be the first one, D would be the second one, plus B cross C plus B cross D. So this is law of distribution. Okay, now let's talk about, these were the formulae on which the question will be directly based. Let's talk about one more approach here. So let's say I have some vector A, right, and some vector B. Okay. And I want to find out a vector which is perpendicular. I want to find out a vector which is perpendicular to both A and B. In that case, I will find out A cross B. A cross B will be a vector which is perpendicular to both A as well as B. Right? So this is an important application. Now, can I remove this?
Yes, sir.
Okay. Now, application will be such that you will be given A vector and B vector. If A vector and B vector are given, then a vector perpendicular to both A and B will be A cross B, right? Now, what I'm trying to find out here is then a unit vector perpendicular to both A and B will be, can you tell me what will be the unit vector which is perpendicular in the direction of A and B? Perpendicular with A and perpendicular with B. So a vector perpendicular to both A and B will be A cross B, right? A cross B will be some vector. If I divide it with the magnitude of the same vector, then this is a unit vector. This is a unit vector perpendicular to both A and B. This is a unit vector perpendicular to both A and B. A cross B divided by the same magnitude, A cross B magnitude. And let's say we want the magnitude with our choice. Let's say we want that find out a vector which is perpendicular to A and B and which has a magnitude 8. Then we can multiply the unit vector by 8. So that is an application of the cross product. Now let's start finding out some of the questions. Start with first, find A cross B if A and B are given. So A is given, B is given. Let's find out A cross B. We can directly do this, by the way. IJK 1 minus 7 3 minus 2 2. So this would be what A cross B would be. So to find out this, I into minus 7 into 2 is minus 14, and this would be plus 14, so this would be 0. Minus J, this would be 2 minus 21 plus K, and this would be minus 2 plus 21. Right? So this would be minus 19 plus 19J plus 19k. Your A cross B would be this. You have to find out the magnitude of A cross B. So that would be 19 square plus 19 square. So this would be 2 into 19 square, which would be root 2 into 19. You guys know how to solve determinant, right? Everyone. Fatima?
Yes, sir.
Fatima, do you know how to solve a determinant? You can ask me if you don't know. Okay, in that case, solve question number 2. Find a unit vector perpendicular to each of A plus B and A minus B. You have to find a unit vector which is perpendicular to A plus B and A minus B. And A and B are given to you. First of all, we have to find out A plus B and A minus B. We have vector A and vector B. So from there, we can find out A plus B and A minus B. Then we have to find out the value. We have to find out a unit vector perpendicular to each A and B. Sorry, A plus B and A minus B. So let's talk about what is being asked. Vector perpendicular to, in fact, unit vector perpendicular to both A plus B and A minus B. Now, what we have learned is if you want a vector perpendicular to any two vectors, we have to take their cross product. So if you want a vector which is perpendicular to a plus b and a minus b, right, which is perpendicular to a plus b and a minus b, it should be a plus b cross with a minus b. No, a vector perpendicular to both of these vectors should be their cross product. This should be a plus b cross with a minus b, right? Now, if you take, and you have to find out the unit vector, not just this vector. So this vector would be perpendicular, and its magnitude, if you divide it by this magnitude, then this would be the required vector. First of all, understand this. The unit vector, which is perpendicular to a plus b and a minus b, would be the cross product of them divided by the same magnitude. Guys, did you understand this?
Yes, sir.
Yes, sir.
Okay, tell me, what is a unit vector perpendicular to these two vectors? A unit vector which is perpendicular to these two vectors, a plus 3b and b minus 2a.
A plus 3b cross b minus 2a by magnitude of a plus 3b cross b minus 2a.
Correct, right? And we can further simplify it now. Use the law of distribution, multiply a plus b cross a minus b. Further simplify, and you'll get a shorter expression. So this would be a cross a would be 0, then this would be a cross b minus a cross b, in fact, plus b cross a minus 0, right? So this can be written as b cross a. So this would be 2b cross a divided by the same. So this 2 would get cancelled out. This becomes b cross a divided by the modulus of b cross a. This is a unit vector which is perpendicular to both a plus b as well as a minus b, right? And you can find out the value of b cross a and its magnitude. Okay, solve one question. Solve this. Tell me the final answer.
Got the answer, sir.
What is the answer?
2i by 3 minus 2j by 3 minus k by 3.
Okay, so it should be 8 I cap minus 8 j cap and 4 k cap. Am I correct?
Yes, sir.
Okay. Okay, cool. Let's solve question number 3. If a unit vector A makes angle pi by 3 with I, so it's given that a vector A, this is a unit vector in fact, it makes an angle pi by 3 with I, then pi by 4 with J, and an acute angle theta with K, right? Then find theta and A. Can you guys solve it? You have written the expression for this. Can you tell me how can we write this?
L square plus m square plus n square is equal to 1.
Correct. So by that we can find out theta. What is the value of theta? Okay, it's okay.
I'm doing
Tell me the next process.
Yes, cos alpha, cos pi by L is equal to cos pi by 3, which is 1 by 2.
Correct.
M is equal to cos pi by 4, which is 1 by root 2, and N is equal to cos theta. So
that's
N
how we
is
can
equal
obtain
to 1
theta.
by 2. Yes, sir.
And after that, how do we find AA? Using alpha, beta, and gamma. How can we find out A? Okay, we have solved this example, I guess. I don't know where, I think in direction cosines, where I have told you this. In the starting of direction cosines, we have studied about this. So any vector, any unit vector can be written as cos alpha I cap plus cos beta j cap plus cos gamma k cap. Because cos square alpha plus cos square beta plus cos square gamma would be 1. Hence, any unit vector can be written in the form of its direction cosines. Obviously, alpha, beta, and gamma are the angles that are made by this vector A with x-axis, y-axis, and z-axis. Now, let's say you have to write some vector A. Then you should know what is the magnitude of that vector along with its angles. In this case, in the given question, you have been asked to form this unit vector whose 2 angles are given. So you will find out the third angle and you will just express it in the form of its BCs.
So theta is pi by 3.
Pi by 3. Yeah, correct.
So A vector is 1 by 2i plus 1 by root 2j plus 1 by 2k.
Okay, solve question number 6. So if there's A dot B is 0, as well as A cross B is also 0. What can you conclude about the vectors A and B? So A dot B is 0 either due to, Anji, tell me all the reasons why, how A dot B can be 0.
A dot B can be 0 if either of the vectors are 0 or when theta is 90 degree.
Theta is 90,
And
correct?
A cross B is 0 when either of the vectors are 0 or theta is 0 or 180.
If both are 0, what can you conclude?
Both vectors are 0.
Not both vectors are 0.
Oh,
Either of the vectors are 0.
Either of the vectors.
Yeah. So if both are 0, A dot B as well as A cross B, it means that the angle is neither 0 degree nor 90 degree. They both are 0 due to A or B. Either A or B is 0. We conclude this. Okay. Solve question number 9. Solve question number 9. I know you can solve it very easily. Chalo. Let's solve this. Coordinates A, B, and C. You have to find out the area of this triangle. To find out the area, which formula would you use?
Half A cross B, modulus of A cross B.
Correct. And how do we find out A cross B? I mean, what is A and what is B here?
We can find the distance of AB and BC.
Yes. So for that, we have the coordinates. What is the coordinate of A?
A is 1, 1, 2,
And B is
2, 3, 5,
C is
1, 5, 5.
okay. Let's find out AB. What would be AB? Anyone can tell me?
I plus 2j plus 3k.
I plus 2G plus 3K, correct. We can also find out BC.
Minus
What
I
would be the value
plus
of BC?
2j.
Minus I
Plus 2j.
correct. See, because we have to, we should have taken BA and BC, right? But we have taken AB and BC. So AB direction is this now, and this is this. But that doesn't change the magnitude of the area, right? But in truer sense, we should have taken BA rather than AB, right? but that won't affect the area of this triangle for now. So area of triangle ABC is equal to ijk. This would be minus 6 I cap. I mean the magnitude of this minus 6 I cap. Then this would be plus 3k cap
Minus
plus 3j
3K.
minus 3j.
Yes, sir. Plus 3, sorry.
Yeah. No, you're correct. Should be minus 3. Because it would be minus 3, then there would be a more negative and one more negative, so minus 3j. Also, it doesn't affect our magnitude, either it's plus 3j or minus 3j, but it should be minus 3j, I guess. And k would be what? 1, 2, 2 minus plus 2, 4. 4k.
Plus 4K cap.
So this has to be this, and area would be the magnitude of it. It would be 36 plus 9, 45 plus 16 is 260. And similarly, we can also solve question number 10. We are given the
Sir,
sides A and B.
61 by 2.
It's given root 61 by 2.
Area of a triangle is half
Yeah, correct.
modulus.
This should be half and this. And similarly, we can find out the answer for question number 10. In that case, we will not take half. Now, let's solve question number 11. So this one is a good question. Solve 11th. Magnitude of vector A, magnitude of vector B, also the angle between them. Oh, sorry, we have to find out the angle between them, and it is also given that A cross B is a unit vector. So if A cross B is a unit vector, magnitude of A and B is given. How do you find out the value for sine theta?
Since A cross B is a unit vector, it is equal to 1.
Yes.
And 1 is equal to modulus of A into modulus of B sine theta. So modulus of A into modulus of B is root 2. So 1 by root 2 is equal to sine theta. Theta is equal to pi by 4.
Correct. So sine theta can be written as modulus of A cross B divided by modulus of A into modulus of. The modulus of A cross B is 1. Modulus of A we know. Modulus of B we also know. This is 3 into 2 root 3. I mean root 2 by 3. So this would be 1 by root 2. Hence, theta, that is angle between them, would be pi by 4. Can we also solve question number 12? Easy question, you guys can solve this. Very optimistic about it. B, C, D, 4 position vectors. And these points are forming a rectangle tree. We have to find out the value of two sides, right? We have to find out AB and BC. And then we have to take the cross product of them. The magnitude of this will be the area. Is everyone clear about the question?
Yes, sir.
Yes, sir.
Okay, come to page 458. Okay, page 458. And let's solve question number 7. Let's solve question number 7. Miscellaneous exercise question number 7. Vector ABC given. You have to find a unit vector which is parallel to the vector 2a minus b plus 3c. You have a, b, and c. Yeah, what's the answer? So a unit vector which is parallel to this. Unit vector which is parallel to this would be written as yeah, guys, anyone? Can you tell me how to write this unit vector? A unit vector which is parallel to this. So any vector which is parallel to this will have same direction, right? This direction, 2a minus b plus 3c. But if you want the unit vector, then you have to divide by its magnitude. So this should be 2a minus b plus 3c, right? Should be b plus 3c. You have to divide by the same magnitude. So this should be 9, 9, 18, and 4 root 22. Final answer is this. Okay, solve 10th. You are given two adjacent sides of a parallelogram. You have to find the unit vector parallel to its diagonal. So we have talked about this, diagonals and area of a parallelogram. You have to find out both of them. So let's say this side is some A, this is given to you, and this is some B side. So you have to find a unit vector. You have to find a unit vector which is parallel to its diagonals. Parallel to its diagonals, so you can take any diagonal. I would say find out the vector for both diagonals. Find out for both. Let's say this is C vector. So find out C cap as well as D cap. This is C cap and this is D cap. Find out C cap and D cap. And also the area of parallelogram. You are given vector A is this and vector B is this. Guys, can you solve this? Nazia, how to solve this? First of all, talk about area of parallelogram. Can you find it?
Yes, sir. That is modulus of A cross B.
Modulus of A cross B, right? Now we have to find out a vector which is parallel to its diagonal. So we have written this. How can we write the diagonals of a parallelogram in the form of its sides? That was in parallelogram law of addition. Can you just revise that and tell me what are the two diagonals in the form of A and B? So if you write C vector, that can be written as A plus B.
A plus B.
Yeah. And if you write D vector, that can be written as A minus B or B minus A, right? Anyone. So just write plus minus with this, right? So you have to write C cap. C cap would be A plus B divided by modulus of A plus B. So this would be 3i minus 6j plus 2k. And this would be 9, 36 and 9 will be 41 by 7. C cap would be this. Then D cap would be plus minus A minus B divided by modulus of A minus B. This would be I cap minus 2j cap plus 8k cap. And we'll apply plus minus divided by 69 root over 69. That is how we can write a vector which is parallel to the diagonals of this parallelogram. And obviously the area is much simpler. This can be found out using magnitude of A cross B. And magnitude of A cross B in this case would be 12 plus 10, 22i. And this would be minus 6, minus 5, minus 11, plus 11j. And this would be minus 4 plus 4, 0. 22i plus 11j, and this should be 11 root 5. Like this. We'll solve this whole miscellaneous exercise. So we'll take the doubts from vectors first, and then we'll move on to 3D the next class. And guys, you will have an extra class on Tuesday. Everybody from class 12th. Same timing. Are you guys available? Fatima, Sakina, and Nazima?
Yes, sir.
Yes, sir.
Okay. Okay, so at the same timing last week, as we have conducted the classes on last week, so timing will be same, and you will have an extra class on coming Tuesday. as well as Thursday. I guess we will be completed by Thursday. Or if not, then we'll be completed by the next week. With all the doubts also. And then we'll have some doubt sessions, guys. So start practicing now. I think it's very close. Boards are too close now. So start practicing and you can ask me your doubts. We'll have some extra doubt sessions also. Sure, then we'll meet on Tuesday.
Thank you, sir.
Thank you, sir.
Sure.